In this quick video, we're going to talk about some Python and Java concepts that will help um, introduce the concepts of the course. Again, we're going to learn on day one some very simple data types and print statements, and do a lot of exercises that will build your ability gradually throughout the course. Today, we're going to try to kind of jump in the deep end so that we can recognize some parts, and then, like the slide here says, coding with a boost, AI-powered learning for beginners. We're going to rely on AI to give us a lot of scripts that we can then identify and recognize parts of based on the slides that you're going to get today. So in this video, we're going to look at these concepts: data types, Boolean expressions, using Boolean expressions in selection, iteration, and procedure. So those 5 concepts. And I think that'll help with your ability to understand and look at some code, Python or Java, and recognize the parts, like I said, and hopefully build some confidence as you enter the course. So data types generally are like little snippets of information, right? So we have, is it a number? Is it a text? Is it, is it a collection of things, right? So it can be a variety of things. Each of those represents information in some way. Maybe it's a number, maybe it's a piece of text, and we're going to go through there. Boolean expressions. Booleans are just trues and falses. So how do you translate information into trues or falses? Selection is lets us use decisions, like I said, Boolean expressions, to make some decisions in our code. So if this occurs, do the thing. And then iteration helps us repeat tasks. And all of these things fall under, will be used together to create a procedure that you will be able to call and have some flexibility and reusability in your code. So let's start with data types. Data types in Python and Java, these are kind of like the basic building blocks of programming. So Booleans, like I said, are trues and falses. Imagine like a light switch. Is it on or off? Those are the states that a Boolean can be. Booleans are similar in Python and Java. Just obviously it's a true or a false. It represents one bit, 0 or 1, right? It's a binary, 1, 0. And yeah, so those things are Booleans. And then numbers. We have integers, whole numbers, like 10 or -5. And then we have decimals like 5.2 and 3.14. Or, yeah. In Python, decimals are pretty much all kind of the same. We don't define them in much different doubles and floats. In Java, there are 2 different data types, doubles and floats, and that has to do with the amount of decimal places and the amount of memory that is allocated for those particular items. All of this will be way more clear when school starts, but I want you to be able to recognize them. And you would see a decimal is a decimal number, and then a whole number as an integer. Those are the 2 basic types of data. Then we have some more complex types or non-primitive types, text and collection types. So text, we use text to store words or phrases. In both Python and Java, strings is what you call these. Strings handle words and phrases. Java also has a data type called a char. It's a character, so a single character as a char. And when you would use that is if you're looking for a particular character in a string, or you're looking to see if a word starts with a character or something like that, you might use char. Then we have collections. Collections are lists. So imagine like a shopping list. It holds a lot of different items. In Python, lists are like this, storing items of your list. Python also has what's called a set, which is unique items in a list. Doesn't allow any duplicates. And then it also has dictionaries. Dictionaries are like lists, but they're made up of paired keys and values. And we're going to see that here in a second. Java has two collection types, primary collection types, arrays, and which are just for a list of information, and resizable ones, which are called array lists. So let's see those. Here in a second, we'll see some of that. Print statements. Print statements are how you see your variables and how you see code in both languages. So in this case, I have a username. My username is the person's name, Ben, and I print that out. Python has a print statement. It's the word print, open parenthesis, whatever you're trying to print. I can print a variable, in this case, username, or I could print the string itself with quotes Ben, or I could print a number, I could print a decimal, or I could print true. I can print all of these types of information. I could print just a string of text, hello Joe. You would put that in the parentheses. In Java, the same idea. We have a string is the variable type, username, Ben. System out print line is the way that Java does a single print. So system out print line with a variable name. They're doing the exact same task. You can see the output here, Ben and Ben. Boolean expressions. So before we really start to think about if and else and conditions like that, we need to look at Boolean statements on their own, right? These are expressions that result in something being true or false, like is 5 greater than 1? Is 8 less than 5? Is 5 equal to 5? All of these things will result in a true or a false. You can also check to see if they're equal, like with the double equal sign. These are, you'll see that these work a little bit differently with text in Python and Java. But yeah, so let's look at the example here. We can understand that 5 would be greater than 1. That is true. 8 is less than 5. That is false. 5 is equal to 5. That is true. 8 is not equal to 8. That is false. And then you could see the greater than and equal to or less than and equal to. Once we get into looking at lists and things, we could say, like, is this item in this list? Or does this list contain, or does this string contain this substring, that kind of stuff. Those would also return a true or a false. And if those conditions got met, then some other part of code would run, which we'll see next. So again, Python, you see that username is equal to Ben. Is username equal to Ben? It prints true. And with Java, similarly, you see the string, and then we can't do a double equal sign because double equal sign checks to see if they are the same object in memory. With Java, it gets a little tricky, so we use a dot equals, and a dot equals with strings would confirm, is that text equal to the value of the other text? So that, again, understanding Booleans helps us work with selection, which we're going to see now. So we do selection all the time in our life, right? If you can imagine, you're getting ready in the morning, you decide with if statements kind of what to wear to school. If in an if statement checks a condition, like is it raining? So in any of these conditions, checks and returns a logical true or false. So if it's true, do the thing. If it's not true, then continue on looking for the next true, or if that's the end of your code, that would be the end of your code. We'll talk in the next slide about how to do else, but you can get the idea here. If a condition is true, it then does this. You can see this right here. And then if in the case of multiple conditions with an and, again, this is in Python, with an and, both conditions have to be true. So if it's raining, should I bring an umbrella? So if it's raining, true or false, I'll bring the umbrella. If it's not true, next. And then in this condition where if it's colder than 70 degrees and I'll spend more than 10 minutes outside, then I will bring a hoodie. That's just a way of thinking. If it's less than 10 minutes, I probably don't need a hoodie. I'll just kind of tough it out. But if I'm going to be out there longer and it's kind of chilly, I might make sure I bring a hoodie. And then there's also conditions where the true is not met. This is an else. So if it's raining, I should bring an umbrella. Otherwise, leave the umbrella at home, right? So you can use that else as a condition when it is not met. See these codes, these are just showing some ifs in Python. If the player coin is 100, player lives goes up. Then you reset the player coins. This is kind of like a scenario where, let's say in traditional Mario Brothers, you collect enough coins that you get an extra life. And you would say, if you collided with another coin, if the coins are greater than 100, you reset this. Otherwise, you just add a coin. Same idea down here in Java. We have an integer player coins is 100. The player lives is 1. We set these values so that they can change. So I check to see if the player coins is greater than 100. Player coin right now is not greater than 100, and it wouldn't run the stuff within this, right? So if this value at 100 is not greater than 100, it is equal to 100. If this was greater than or equal to 100, then I would see this player lives plus 1 player coin go down. So it's only once you're at greater than 100 that this is changing. Then we have collection types. Collection types, like I said on the first slide, are just storing types of data. So we're going to look at a couple different types of data, but just think of them as like bins or buckets or lists. We use the word lists in Python, and you could think of it the same idea. Like I have a grocery list or I have a to-do list. It is a set of things. In this case, with Python, you can see that these are a grocery list: eggs, bread, milk, milk. Then I convert something to a set. In this condition here, it says grocery list is now equal to the set of grocery list, in which I removed duplicates. So eggs is gone, milk is only going to occur one time. Dictionaries, like I said in the earlier slide, dictionaries go beyond just simple lists. They store key value pairs. So like in this case, brand has a value, model has a value, year has a value, and they alternate with commas separating them. We'll see an example of when dictionaries are in application in a couple slides. And then same thing happening in Java. We have a simple array. So in this case, I have created a new array. An array is of type string. All of these are text, so they are going to show as strings. And that stores that same information in Java. I also have an array list. An array list, I create like the bucket that I'm going to put things into, creating an empty array list, and then I add them one at a time, or eventually I could potentially add them using iteration. So if I had a robot or some sort of sensor that was checking every minute to do something, I could say, wait a minute, check to see if this occurs. If it occurs, add it to my bucket. Repeat and repeat and repeat. And that's through iteration that we'll see that. That's pretty much the most common ways to do array lists in Java. Then we want to talk about how do we access these things. So I've got a list, but I want to get a specific item from the list. How do I check that? Both Python and Java work on a 0 index, so the position or the index in a list. So eggs is at the 0 position, bread is at the 1 position, and so on. In Python, you use the hard brackets, starting of what position you're looking for. Same thing with arrays. They're very similar. To think of arrays working with and accessing, at least in Java and Python, arrays and lists are functionally the same. With array lists in Java, we use the method called .get. So how do I get what's at the 0 position? So I've created my list, eggs, bread, milk. What's at position 0? Eggs. And that's the syntax for that. Iteration. We're going to talk about 3 different types of iteration: while loops, for loops and a for each loop. While loops occur while a condition continues to occur until a condition is no longer true. So as long as a certain condition remains true, keep running this code. Sometimes what students find is that might mean forever, or until you stop the code, interrupt the code from running because there's not a change in your condition. So while I is less than 5, print I, and then add 1 to your I. And that's what's occurring here in Python and in Java. So I start at 0. I want to go up until I'm going to go 0, 1, 2, 3, 4. I'm no longer less than 5. Go through that, right? So print those values, add 1. Both of those are functionally the same. I have a for loop in a range. So I want to go do a task or do something set number of times. Print hello, Mr. Reed, 50 times. Okay. For I in range, print hello, Mr. Reed. And you're going to print, if you put in 50, it's going to print it 50 times, right? So, yeah, so starting, and in this case, we only have an endpoint. So you don't have a starting point for where you're starting a range. If you wanted to print from 1 to 50, you would say for I in range 1, comma 50. And again, excluding, so it would print 1 to 49. And in our example down here, we would start at 0. Again, it's going to always start at 0. In this case, range, it would print 0, 1, 2, 3, 4. And the same thing is going to happen down in the Java, 0 up to, but not including 5, 0, 1, 2, 3, 4. So that's a for loop. And then a for each loop. And this is where you really rely on those collection types. So I want to go over all the elements in a collection. So maybe it's a list or an array list or an array. I want to go through them and do something with them. Analyze them. I want to combine them, sum them up. I want to find the biggest or the smallest of something. I'm going to go through each of those everything in my list to check it. So in this case, I've got a for fruit in fruits. Fruits is my list. Print out each fruit. And the same thing's occurring in Java. So I've got an array of type string, apple, banana, orange, for every fruit in fruits. So again, this is like the for each fruit in fruits, for each whatever in whatever. You're going to, right, for every item string in my list of names, for every name in names, however you would, that's, you're always going to have a singular is what you're checking in a non-sync plural item. So again, the collection type is, our example here in a second, we're going to see, we'll show a for each, and you'll see how that works in practice. So again, it's going to have those words for, or it's going to have the word while. These represent iteration. And the procedure. Procedure is something that's going to repeat. So a procedure, like I said, is a repeatable, reusable block of code. Procedures will have, you write a procedure once, and you can use it over and over and over. There's no more copying and pasting of that same code. Procedures can allow you to put in inputs, which is like a parameter, and often they will output something. So maybe it's a task it repeats, or it's a value it's calculated and then returns of that value. So we'll see those in examples here. So in this case, I've got a Python procedure. Python, the word for procedure is function. So you're going to create lots and lots of functions this year. Functions in Python look like this. They all start with the word def. Def indicates that you are defining a function. It's got a parameter. Our parameter is a placeholder name, and then we use that placeholder in the indented code below. When I call the function, I don't need the def, I don't need the colon, I now need the placeholder to be filled with something specific. So I can imagine the word Beth going into the word name up above, right? So if I draw a little line up here, that name gets included in here. What would happen? Hello, Beth, exclamation mark. We see that all working. So again, defining your function, calling your function. Java works a little differently because they're often separated methods. The word for procedure in Java is method. And they work similarly. We have parameters and we have values. In this case, I have a task that I want this code to do, print, just that we have in Python. Python has take this name, print that string. In Java, we say, I need you to print out hello with the parameter, the name with an exclamation mark, and I call that function over here, greet Beth. It looks identical to the Python. If I don't have a return and I just have a task, in this case print, that's a task, this would be a void method. Imagine I have a scenario where I want to take in a string and I want to return or tell me the length of the string. How long is that? How many characters are in that string? Then that's going to be a number, an integer. I would then return, this would be an integer, greet, public static int greet, with everything else would be the same, in which case I would return an integer type. So this will all be very clear. This is Unit 4 in the Java class, and I think we'll be very comfortable with different data types and how basic methods work at that point. But I want you to be able to recognize it because we're going to see some code here in a second. And then I would encourage throughout the summer that you're looking at Python or Java based on your course and getting some sense of those key components. Okay, so bringing all this together, the goal here is that we're going to use AI this summer to find snippets of code and see the concepts that were discussed here out in the world. So here's my prompt that I posed to Google AI Gemini. Write a Python script to find the biggest number in a list. And this is the returned code. So find biggest number, takes in a list of numbers, nums, and it's going to go through and eventually return the biggest number. Like any example, when you're looking to evaluate things, the first thing that you see will be the biggest, smallest, longest, tallest of the things you've seen thus far inherently. So in this case, the first position, index 0 of nums, is my biggest number. And then I want to go through that whole list of numbers and check to see if they're bigger. And if they are, I reassign the biggest number to that. Eventually, I return biggest number. And I see that I shared a list of numbers down here on line 8. And I called my method or function, this is a Python, called the function find biggest numbers, which is, I can see this here, down here, storing it to text. And then I print that out. And I brought all these parts together. Okay, so where do you see selection? Where do you see iteration? Where do you see some sort of list or collection type? Where's that list getting plugged in or used? And how do you see that list getting accessed? Where's the procedure? Does the procedure have a parameter? Parameters, again, are something in the parentheses here. And where is that procedure then called, right? So I see the function, def, find biggest number, takes in numbers, and I want to call it somewhere biggest number. Find biggest number should be find biggest number. Takes in my list of numbers. So I'm going to show how this works. So line 4 for selection. And what we're going to do once we get to class, we'll see throughout the year, is we're going to be using a lot of highlighters. Because these things will correspond to concepts. And you can see that I have my procedure is blue. My procedure call, in this case, is purple. And I'm going to try to do this throughout the year as this code starts smaller. Obviously, this is much bigger than we're going to start, but I think you'll get the gist as we go along rapidly. Here's another scenario. Write a Java program to find the fastest lap time in my race. So I'm assuming that I'm going to give it an array of decimal values, because I got to check each lap has decimal values, and I'm going to go through that list or array, and check to see if they're bigger than or smaller than the previous one. If they're smaller than the previous fast time lap time, then I know that they're gradually getting faster, and as a result, I'm going to eventually find the fastest lap time. If the first one is the fastest, I go through the whole list, and it'll still be the first one. That'll be great. Okay. So here's my list of numbers over here. Double. Here's all the numbers. And I say, find the fastest time. So it calls this method. This method is going to eventually return a double 2. And it takes in an array of type double. Find the first one. Go through every lap time in my lap times. If that time through is smaller than my fastest time, it now becomes the fastest time. And then eventually it's going to get called over here, and that fastest lap time gets printed out. So let's break it down. Is there selection here? Is there iteration here? Is there a list getting used or a collection type? Is that list getting accessed? Is there a procedure or a parameter here? Know that in Java, a procedure is called a method. So we see, where do they occur? So here's my procedure. Does it have a parameter? It does. Takes in lap times. Then where's that lap times get used? The list is getting accessed lap times of first position, and then I'm going to use it as I go through my entire array of lap times. And then here again is the main method where I see the actual array of type double. These are all decimal values. These are going to represent the different speeds of my laps. And then I call the method, notice that. So again, some of those parts were already on the other side. Where's the list? Where does the list exist? On line 14. And then where's that procedure getting called? Over here. And I'd say those 6 items, selection, iteration, list, a list getting accessed, procedure getting defined, and a procedure getting called, we're going to be doing over and over and over throughout the year. So you're going to get a lot of examples, and I think that this method will help you be able to recognize some parts and hopefully be able to write strong code throughout the year. Here's another example. Write a Python script to find the tallest student in the class. So I've got our method here, find tallest. The tallest student is obviously the first student I have. This method is different, or this function is different because I've got a list of dictionary. I've got a dictionary here, right? So each one has a name and a height, name, height, name, height. And when I do that, I will access the height component against the tallest. So it's checking in students the first item, which again, each one of these represents one item, pairs. If that item's height is taller than the other tallest, then the student that is the tallest is now a student. So when it gets printed out, it's going to say their name. It's also going to say their height. So where's selection? Again, selection, we're looking for an if or an else. Iteration, we're looking for a for or a while. List, we're looking for brackets, or that's probably the starting point. Where is that list going to get used? Where's this student? Right, the students, line 8 is a collection type, gets plugged in as my parameter. I get it called down here. Find tallest, takes in this list, goes through this, and then gets used throughout. So line 4 for my selection, line 3, and you get that idea. A coach asked for shirt sizes for all the players on the team. Write a Python script to determine the count of shirts for each size. So this is a real world scenario that you can think about. You're in a club, or you have something. This is something that could very easily be is a codable solution, codable problem. So here we are. I've got my function def count shirt sizes, takes in a bunch of shirt sizes, and I want to find the unique sizes, and I want to find the size counts. Great. So I can look through this. You don't have to understand all of these parts, but you should be able to recognize some of the code. So where do I have selection? Again, selection, I'm looking for if and an else. Got iteration up here inside my function. I also have iteration down here on line 18 for to go through the shirt counts and make sure that I have the right number for each of those particular shirt sizes. So these are all examples of what are called computational problems. So these are scenarios that can be solved step by step with a computer or algorithm. And this is my last slide, and my kind of request is that you take some time this summer, whether you're going to take Python CSP or Java CSP, a robotics CSP, or you're looking to begin exploring CSA, which is again Computer Science A, which is a Java course. Craft your own AI prompts. Maybe, and I can give you some examples here, right? So I'm looking to learn computer programming through reviewing AI created code snippets. What are 20 good prompts to get an introductory Python functions that use iteration, selection, and lists? Right. So if you can imagine that kind of text, paste it into ChatGPT or Gemini or any other AI tool that you would like to use, you're going to see a lot of examples. Analyze those code samples. Don't be sad or concerned if you don't understand everything. That's totally okay. You've yet to begin a coding course. But you should be able to recognize some of these elements. Print the file out. Highlight it. Put it in it, copy and paste it into a Google Doc. Highlight it in the Google Doc. Recognize these parts. Highlight what you feel, what seems familiar, and do it again. As you review and continue to review this AI-generated code, you're going to see how functions are structured. You're going to see how they interact with lists. You're going to see how they use leverage and selection to achieve some sort of task. Again, highlighting the keywords in the syntax will build like these connections for you, and also your confidence as you approach the course. And again, don't be saddened if it doesn't come immediately. Coding is time consuming and not usually something that is immediately connected or immediately understood. We'll build. The coding uses this concept all the time called iteratively. We'll build our understanding iteratively too. So at the beginning, we'll understand some parts. We'll get it to do something. Then we'll build on that and build on that and build on that until we have fully functioning code that can do complex tasks. Your goal really at this point is, what are the parts? What are the key parts of code that we'll be writing? And can I see them in scenarios that mean something to me, right? So give me an example of a code that does XYZ. Make a list of names and find the average length of name, right? So you're gonna need to figure out how to make a list of names, check those lengths of names, add those lengths to a running total, and then divide that by the number of, all of those things you're going to eventually understand how to do. Right now, the goal would just be, where's the function occur? Where's the iteration occur? Where's the selection occur? How is it incorporating that list? What does that list look like? All those kind of questions will help your understanding as you approach this course this fall. So thanks for watching, and I really appreciate your time, and I hope you have fun using AI as a tool for developing some understanding of these concepts. Feel free to review this video as many times as you need, and I'll also share the slideshow so that you have access to look at that as well. Have a great summer.